Good afternoon, ladies and gentlemen. My name is Ari Rahayuning Tyas. I come from Research Center for Appropriate Technology, Indonesian Institute of Science. I will present about my project with the title is Automation and Monitoring System of Drying Parameters in Cabinet Drying using Arduino, Temperature and Humidity. And my team are Novita Dwi Susanti and Diang Sagita. The presentation is divided into 4 parts: introduction, experimental equipment and procedure, result and discussion, and conclusion. The introduction. Drying is a process to remove water from the many kind of product. There are 2 groups of factors that affect drying. The first, the factor related to the environment are temperature, the volumetric velocity of the drying airflow, and humidity. The second, the factor related to product characteristics are size of the material, the initial moisture content, and the partial pressure in the material. In conventional drying, it still uses sunlight, which requires a large drying area and a long drying time. Types of artificial dyes have been developed. One of them is cabinet dye, which does not require large space and can be dried all the time. The rapid development of internet technology allows it to be applied to dryers equipment so that drying parameters can be monitored remotely. Experimental equipment and procedure. The method used in its study was design and manufacturing a prototype. It was focused on the design of hardware and software for automation and monitoring system. Figure 1. Block diagram of component used in the system. Based on Figure 1, the drying room was equipped with 3 temperature and humidity sensors. 2 sensors were installed in the drying room and 1 sensor was installed outside of the dryer. The temperature and humidity value will be processed by Arduino microcontroller, then the data was displayed on LCD. The flow diagram automation and monitoring system setting temperature and humidity can be seen in Figure 2. Begin from start, then initialization, so the data will be processed. If the humidity average more or same with humidity environment -50, exhaust fan will on. If not, the process will be end. If average temperature less or same with temperature setting, solenoid valve will on. If not, process will be end. If the average humidity less or same with 50, blower will on. If not, the process will be end. The data can be accessed through Android platform by using an internet connection. For the access, the application needs user authentication. Then the user can monitor the drying condition using blind application. The procedure can be seen in Figure 3. Figure 4 is drying room and layout of sensor. The illustration of the cabinet dryer. The drying room has a size of 2000 × 2000 × 2000 millimeters with capacity of 30 until 44 kg per batch. There are 2 racks with the capacity of 20 trays per rack, complete with temperature and humidity sensor that can be arranged according to the product that will be dried. There is an exhaust fan to release the water vapor to the environment. Another blower has a function to blow and even out the air to the drying room. The temperature and humidity regulation system in the drying room was designed to the automatic and can be monitored by Android platform. The dried product was thin sliced cassava with a thickness around 2 until 3 millimeters. The temperature was set on 55 derajat Celsius. And the result and discussion. The sensor used DHT22 and the data was obtained from 5 times of observation. Temperature range 33 until 37. Table 1. The measurement performance of sensors DHT22 and standard instrument. The sensor reading has different value than comparing with standard measurement. The average error of the sensor is 0.5 with deviation is 0. So, to increase the accuracy, correction of different value reading is needed. Can be seen on figure 5. In table 2, the average value of sensor reading is 10 times replication every 30 minutes is 50.79 and the deviation is 0.07. Performance of temperature and humidity monitoring system in cabinet dryer. Figure 6. Profile of temperature and humidity in the drying room without load. Figure 7. The data echoed in monitoring system temperature and humidity in drying room with load. Figure 8. The visualization of the recorded temperature and humidity data in the drying room by blind application. The conclusion. The DHT22 sensor reading error value is very small, namely 0.5 derajat Celsius and deviation is 0 derajat Celsius. The repetition every 30 minutes was 50.79 derajat Celsius, but deviation is 0.07 derajat Celsius. The moisture content of the dried cassava slice decreased from 68.72% to 70% during 7 hours of drying. The system can monitor the performance of dryer in real time for 24 hours via blind Android. The distribution of temperature and relative humidity was quite uniform at the top and bottom of the drying chamber during the monitoring process. It is enough for my presentation, and thank you very much.